Ladies and gentlemen, this is not just a factory opening. This is the moment the future of manufacturing comes alive. On a scale never seen before, steel software and energy come together under one roof to redefine how vehicles are built, how power is stored, and how innovation moves at full speed. What you're about to witness is a transformation where machines learn, factories think, and sustainability scales to levels the world once thought impossible. Stay with me, because this single facility is reshaping transportation, energy, and the very idea of what a factory can be. And the official opening of Gigafactory Texas represents a defining moment in the evolution of advanced manufacturing, sustainable energy, and large-scale innovation. Built with speed, precision, and purpose, this facility reflects a commitment to rethinking how factories are designed, how vehicles are produced, and how energy systems are integrated into one seamless ecosystem. Gigafactory Texas is not just a production site. It is a statement about the future of manufacturing and the role technology plays in accelerating the transition to sustainable energy. And located on a vast site, the factory is engineered to maximize efficiency at every level. From its structural design to its internal workflows, every detail is optimized to reduce waste, lower energy consumption, and increase output without compromising quality. The building itself incorporates sustainable materials and energy-conscious architecture, enabling large-scale operations while minimizing environmental impact. This approach demonstrates how industrial growth and environmental responsibility can move forward together. And inside the factory, manufacturing systems operate with an unprecedented level of integration. Vehicle production, battery technology, and energy storage solutions are developed under one roof, allowing faster iteration and continuous improvement. Advanced automation works alongside skilled human expertise, creating a balanced production environment where precision and adaptability coexist. This synergy allows the factory to respond quickly to demand while maintaining strict standards of safety and performance. And Gigafactory Texas plays a critical role in scaling next-generation vehicles. Designed to support high-volume production, it enables faster delivery to customers while reducing logistical complexity. By producing vehicles closer to key markets, transportation emissions are reduced and supply chains become more resilient. This localized manufacturing strategy strengthens efficiency and supports long-term sustainability goals across the entire operation. And energy innovation is at the core of the facility. The factory is built to integrate renewable energy sources and large-scale energy storage, showcasing how industrial operations can rely more heavily on clean power. On-site energy systems help stabilize consumption, reduce peak demand, and demonstrate real-world applications of advanced battery technology. This not only powers the factory itself, but also serves as a model for how future facilities around the world can operate with greater energy independence. And beyond manufacturing, Gigafactory Texas is designed as a hub for innovation and growth. It brings together engineers, technicians, and specialists who work collaboratively to push the boundaries of what is possible. Rapid prototyping, real-time data analysis, and continuous testing are embedded into daily operations, enabling constant refinement of products and processes. This culture of innovation ensures that improvements are not occasional milestones, but ongoing outcomes. And the factory also represents a significant investment in the local economy. Thousands of jobs are created across engineering, production, logistics, and support roles. Training programs and skill development initiatives help build a workforce prepared for the demands of advanced manufacturing. This strengthens the surrounding community while contributing to a broader shift toward high-tech, future-ready industries. And Gigafactory Texas reflects a broader vision of vertical integration, where design, manufacturing, and energy systems are tightly connected. This approach reduces dependency on external suppliers, improves quality control, and accelerates development cycles. By bringing critical processes in-house, the company gains greater control over innovation timelines and product performance, ensuring that advancements reach customers faster and more reliably. And the opening of this facility signals a new chapter in how large-scale factories are conceived and operated. It shows that speed, scale, and sustainability do not have to compete with each other. Instead, when technology, design, and purpose align, they create systems capable of reshaping entire industries. Gigafactory Texas stands as a living example of what is possible when manufacturing is reimagined from the ground up, built not only for today's needs, but for the demands of a rapidly changing future. This reimagined approach extends beyond production efficiency and into how products are engineered from the earliest stages. Gigafactory Texas enables a feedback loop between design and manufacturing that shortens development cycles and improves real-world performance. Engineers can observe production data in real time, identify opportunities for optimization, and rapidly implement changes directly on the factory floor. This tight connection between concept and execution allows innovation to move at a pace traditionally unseen in the automotive and energy industries. And manufacturing techniques within the facility redefine scale and simplicity. Large single-piece castings reduce the number of components required, lowering complexity while increasing structural integrity. Fewer parts mean fewer robots, fewer processes, and fewer opportunities for error. This streamlined philosophy allows vehicles to be produced faster, with improved consistency and reduced cost while maintaining high standards of safety and durability. It represents a fundamental shift in how vehicles are built, moving away from fragmented assembly toward integrated structures. And software plays a central role in how the factory operates. From logistics planning to quality control, digital systems continuously analyze data to optimize performance. Production lines are adjusted dynamically based on demand, supply availability, and real-time efficiency metrics. Predictive maintenance systems help identify potential issues before they occur, minimizing downtime and ensuring smooth operations. This software-driven approach transforms the factory into a living system that learns, adapts, and improves over time. And battery development and manufacturing are deeply embedded into the facility's purpose. Advancements in cell design, packaging, and thermal management are implemented directly into production, allowing energy storage technology to evolve rapidly. These improvements contribute to longer range, faster charging, and improved longevity not only for vehicles, but also for stationary energy storage solutions. By refining battery technology at scale, the factory supports broader applications across transportation, energy grids, and renewable infrastructure. And the physical layout of Gigafactory Texas is designed to support growth far into the future. Production capacity can be expanded without disrupting existing operations, allowing new technologies and vehicle platforms to be introduced efficiently. This flexibility ensures the factory remains relevant as technology advances and market needs change. Rather than being locked into a single generation of products, the facility is built to evolve continuously. And automation within the factory is balanced with human ingenuity. Advanced robotics handle repetitive and high-precision tasks, while skilled teams focus on problem-solving, innovation, and quality assurance. This collaboration enhances productivity while maintaining accountability and craftsmanship. Training programs ensure that the workforce grows alongside the technology, developing expertise in robotics software and advanced manufacturing systems. And supply chain integration is another key strength of the facility. By producing critical components on-site or nearby, reliance on long-distance shipping is reduced. This improves resilience against global disruptions and allows greater control over materials and quality. Shorter supply chains also reduce environmental impact, aligning operational efficiency with sustainability goals. And the factory's presence reinforces a broader mission to accelerate the adoption of sustainable technologies. Vehicles and energy products produced here are designed to reduce reliance on fossil fuels and support a cleaner energy ecosystem. Each unit produced contributes to a larger network of renewable generation, storage, and efficient transportation, amplifying the impact beyond the factory walls. And Gigafactory Texas also serves as a proving ground for future factories worldwide. Lessons learned here influence how new facilities are designed, built, and operated across different regions. Innovations in layout, automation, energy use, and workforce integration are scaled and adapted globally, creating a ripple effect throughout the manufacturing ecosystem. And as operations continue to ramp, the factory becomes a focal point for collaboration between engineering, production, and energy teams. This convergence enables breakthroughs that would be difficult to achieve in isolated environments. By uniting multiple disciplines under one roof, the facility accelerates progress toward more efficient products and smarter systems. And every aspect of Gigafactory Texas reflects a deliberate effort to rethink industrial norms. It challenges the assumption that large factories must be slow to adapt, resource-intensive, or environmentally burdensome. Instead, it demonstrates how scale can amplify innovation, how efficiency can support sustainability, and how technology can transform manufacturing into a dynamic, forward-looking system driven by continuous improvement. And this continuous improvement mindset shapes how materials are selected and utilized throughout the factory. Advanced material science enables lighter, stronger components that improve efficiency without sacrificing safety. Aluminum alloys, high-strength steel, and innovative composites are chosen not only for performance, but also for recyclability and long-term sustainability. By reducing material waste and increasing reuse, the factory aligns industrial output with environmental responsibility at scale. And the integration of digital twins further enhances operational intelligence. Virtual replicas of production lines and systems allow teams to simulate changes before implementing them in the physical environment. This reduces risk, saves time, and ensures that adjustments lead to measurable improvements. Data from sensors across the facility feeds into these models, creating a closed-loop system where insight directly informs action. And quality assurance is embedded into every step of production rather than treated as a final checkpoint. Vision systems, automated inspections, and real-time analytics monitor components as they move through the factory. Deviations are detected immediately, allowing corrective measures to be taken before issues propagate downstream. This proactive approach increases reliability and ensures that every product meets stringent performance and safety standards. And energy efficiency remains a central focus as production scales. Intelligent energy management systems balance loads across the facility, optimizing usage based on availability and demand. On-site energy storage smooths fluctuations and supports continuous operation even during peak periods. This approach demonstrates how large industrial sites can operate with reduced dependence on external power sources while maintaining high throughput. And water conservation and responsible resource management are also prioritized. Advanced recycling systems minimize freshwater consumption by treating and reusing process water. These measures reduce strain on local resources and set a benchmark for sustainable industrial practices. By addressing energy, water, and materials together, the factory operates as an integrated system rather than a collection of isolated processes. And the human experience within the factory is designed to support safety, efficiency, and collaboration. Ergonomic workstations, clear workflows, and data-driven decision tools help teams perform at their best. Safety systems leverage automation and monitoring to reduce risk, creating an environment where innovation and well-being coexist. This emphasis on people ensures that technological advancement is matched by a strong operational culture. And logistics within the facility are optimized for speed and precision. Autonomous transport systems move components seamlessly between production areas, reducing delays and manual handling. Inventory levels are dynamically adjusted based on real-time production data, minimizing excess storage and improving flow. These logistics innovations contribute to shorter production cycles and more consistent output. And the factory's role in advancing electric mobility extends beyond vehicle assembly. Continuous improvements in drivetrain efficiency, power electronics, and thermal systems are implemented directly into production. These refinements result in vehicles that deliver improved performance, reliability, and user experience. By iterating rapidly at scale, the factory accelerates the pace at which technological gains reach customers. And manufacturing at Gigafactory Texas also supports the broader energy ecosystem. Large-scale energy storage solutions produced here help stabilize power grids and enable higher adoption of renewable energy sources. These systems play a critical role in balancing supply and demand, supporting grid resilience and reducing reliance on fossil fuel-based generation. The factory thus contributes to energy transformation at both the consumer and infrastructure levels. And collaboration with suppliers and partners is guided by shared standards of efficiency and sustainability. Materials, components, and processes are evaluated not only on cost and performance, but also on environmental impact and scalability. This collaborative approach raises expectations across the supply chain, driving innovation beyond the factory itself. And as production volumes grow, data-driven insights continue to shape decision-making. Machine learning models analyze patterns across manufacturing, logistics, and quality metrics to identify opportunities for further optimization. These insights enable continuous refinement, ensuring that improvements compound over time rather than plateau. And the scale of Gigafactory Texas amplifies its influence on manufacturing practices worldwide. Each advancement implemented here serves as a reference for future facilities, demonstrating how integrated design, automation, and energy systems can redefine industrial efficiency. By proving these concepts in a high-volume environment, the factory helps establish new benchmarks for what modern manufacturing can achieve. And this evolving system reflects a long-term commitment to progress rather than short-term gains. Every process, material choice, and technological investment is evaluated for its ability to support sustained improvement. The result is a manufacturing environment that grows more capable, with time continuously pushing the boundaries of efficiency, sustainability, and innovation. And this long-term perspective influences how the factory adapts to future technologies that have yet to be fully realized. Production systems are designed with modularity in mind, allowing equipment to be upgraded or reconfigured as new manufacturing methods emerge. This adaptability ensures that innovation does not require rebuilding from scratch, but can be integrated smoothly into existing operations. As technology advances, the factory evolves alongside it, maintaining relevance in a rapidly changing industrial landscape. And artificial intelligence continues to expand its role across operations. Beyond monitoring, efficiency and quality, intelligent systems assist with decision-making at scale. By analyzing vast amounts of production data, these systems identify subtle correlations that would be difficult to detect manually. This leads to smarter scheduling, optimized resource allocation, and improved consistency across shifts and teams. Over time, these insights compound, steadily increasing overall performance. And thermal management across both vehicles and manufacturing equipment benefits from constant refinement. Improved cooling systems reduce energy loss, enhance durability, and support higher performance thresholds. These advancements are implemented not as isolated upgrades, but as part of a cohesive system where every improvement reinforces others. The result is a manufacturing environment that operates closer to optimal conditions while consuming fewer resources. And the factory's impact on transportation infrastructure extends outward as production scales. Increased availability of electric vehicles supports broader adoption, encouraging further investment in charging networks and renewable energy generation. Each vehicle produced contributes to a feedback loop where demand for clean energy grows alongside supply, accelerating the transition toward a more sustainable transportation ecosystem. And workforce development remains central to sustaining this momentum. Continuous training programs keep teams aligned with evolving technologies, ensuring skills grow alongside automation and software systems. This emphasis on learning creates a culture where adaptation is expected and innovation is shared. As processes improve, so does collective expertise, strengthening operational resilience. And manufacturing transparency is enhanced through real-time dashboards and performance metrics accessible across teams. This visibility promotes accountability and collaboration, allowing challenges to be addressed quickly and successes to be replicated. By democratizing data, the factory empowers individuals at every level to contribute to continuous improvement. And environmental considerations remain integrated into daily decision-making. Waste reduction strategies focus on reclaiming materials and reintroducing them into production cycles wherever possible. Packaging optimization and localized sourcing further reduce emissions associated with transportation and handling. These measures reinforce the idea that sustainability is not a separate initiative, but a core operational principle. And the factory's design also supports long-term scalability of energy products. As demand for energy storage grows, production lines can be expanded or repurposed without disrupting vehicle manufacturing. This flexibility enables rapid response to shifts in global energy needs, reinforcing the facility's role as a cornerstone of clean energy infrastructure. And advanced testing and validation processes ensure that innovations introduced at scale meet real-world demands. Components are subjected to rigorous stress testing, simulating years of use in diverse conditions. Insights gained from this testing feed directly back into design and manufacturing, closing the loop between performance data and production improvements. And digital connectivity extends beyond the factory floor, linking production with supply networks and distribution channels. This integrated approach improves forecasting accuracy and reduces lead times, ensuring products reach customers efficiently. By synchronizing manufacturing with delivery, the factory minimizes idle inventory and maximizes responsiveness. And as production volumes increase, the emphasis on reliability becomes even more critical. Systems are designed with redundancy and fail-safe mechanisms to ensure uninterrupted operation. This resilience allows the factory to maintain output even in the face of unexpected challenges, reinforcing confidence in large-scale manufacturing of advanced technologies. And the facility's influence on industrial standards continues to grow as proven methods are adopted more widely. Techniques refined here inform best practices across manufacturing sectors, demonstrating how innovation at scale can coexist with responsibility and efficiency. Each iteration builds upon the last, creating a compounding effect that extends far beyond a single location. And through constant iteration, data-driven refinement, and integrated design, the factory embodies a vision of manufacturing that is dynamic rather than static. Processes are never considered finished, only improved. This mindset ensures that progress remains continuous, driven by measurable results, and guided by a commitment to efficiency, sustainability, and technological advancement.